Hello my scholars, this is my school YouTube channel and my name is Frank. In today's video, we are going to be discussing about scalars and vectors. So do not go anywhere, relax and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we are going to be discussing about scalar and vector. So before we begin the lesson proper, let's quickly run through the objective for today's lesson. So at the end of this lesson, number one, students should be able to explain the concept of scalars and vectors. Two, distinguish between scalar and vector quantities and their representation. Three, compose at least two vectors. 4. Explain the meaning of the resultant of two vectors. 5. Resolve a vector into a given direction. 6. Resolve any number of vectors into two components at right angles to each other. 7. Solve simple problems involving resolution and addition of vectors using analytical and graphical methods. So let's begin with the lesson properly. So in physics, physical quantity is divided into two: vector quantities and scalar quantities. So what do we mean by scalar quantity? So a scalar quantity is one which has only magnitude but no direction. Okay, so scalar quantities, they have magnitude but they don't have direction, meaning that when representing them, okay, or when talking about them, you only indicate the magnitude without talking about their direction. Okay, so example of scalar quantities are temperature, volume, area, time, speed, distance, electric charge, electric resistance, electric current, density, etc. They are all examples of scalar quantities. While the other type of quantity called vector quantity is one that has both magnitude as well as direction. So when representing them, you mention the magnitude as well as the direction. Okay, let's take for example displacement. Okay, so in specifying displacement, let's take for example, let's say we have an object is displayed 10 kilometer, so you can go 50-degree northwest. Okay, so the 50-degree northwest is trying to show the direction of the displacement. Okay, so examples of vector quantities include displacement, velocity, acceleration, force, torque, electric field, magnetic field, etc. So let's quickly look at the difference between scalar and vector quantity. So from that definition, you can even pick out their differences. Okay, one, under scalar quantity, a scalar quantity has only magnitude, okay, while a vector quantity has both magnitude and direction. Okay, the direction of scalar quantity cannot be determined. Okay, whereas the direction of vector quantity can be determined. Now, scalar quantity is not represented by line and arrow. Okay, we don't represent scalar quantity using line and arrow, but a vector quantity can be represented, okay, by line and arrow. Okay, a scalar quantity is one-dimensional, while a vector quantity can be 1, 2, or 3-dimensional. So let's move to the next slide. So on the next slide, we are going to be looking at the similarity between both scalar and vector quantity. So one of the similarity between them is that they are physical quantity in physics. When I started, I said physical quantity in physics is divided into two, scalar and vector. So this one similarity between both of them is that both of them are physical quantity in physics, right? Now, from that definition, we said scalar quantity has magnitude, while for vector, we also said it has magnitude. Okay, so another similarity between scalar and vector is that both of them have magnitude. Okay, both of them have magnitude. Then the last but not the least is that their magnitude can be determined by calculation. Okay, the magnitude can be determined by calculation. So here we look at representation of vector quantities. Now remember that we said scalar quantity cannot be represented with line and arrow, right? But a vector quantity can be represented with line and arrow. So let's look at how we represent vector quantity. So a vector quantity is usually represented using line and arrow, right? So the straight line, okay, indicates the magnitude or tells you about the magnitude of the quantity, in this case vector quantity, while the arrow indicates the direction of the quantity, right? So vector quantities are represented with a line and an arrowhead, okay? So the line represents the magnitude, okay? So another word for magnitude is value, or you can say size, okay, of the vector quantity, while the arrowhead represents the direction of travel of the vector quantity, and this is what is shown below, okay? So this is how a vector quantity is represented, and it's represented using a line and an arrowhead. Okay, so let's move to the next slide. So on the next slide, we are going to be discussing about addition and subtraction of vectors. Okay, so two or more vectors acting on a body in a specified direction can be combined to produce a single vector having the same effect. So this single vector is what is referred to as the resultant vector. Okay, so if you are asked what is a resultant vector, just tell them that a resultant vector is a single vector that has the same effect in magnitude and direction as two or more vectors, okay, acting together. So that is just a simple meaning or explanation for the resultant of vector. So let's see some example. Example A1, two forces, y, of course, force is an example of a vector, okay? So two forces, y and s, with magnitude of 3 Newton and 4 Newton respectively, acting along the same direction, we produce a resultant of 7 Newton. So like a rule or a conversion, right? When two vectors are acting in the same direction, what you simply do is that you add the two vectors together, okay? And that is what you refer to as the algebraic sum of the two vectors. So you just sum the two vectors together, and that will be equals to 7 Newton, right? Because the first vector, okay, or the first force, y, has a magnitude of 3 Newton, right? While the second one, x, has a magnitude of 4 Newton, and they are acting along the same direction. Okay, they are acting along the same direction. So since they are acting along the same direction, you sum up the two forces to get the resultant vector, okay, or to get the resultant force. So in that case, we add 4 to 3, and that will give us 7 Newton. Now remember that I said earlier on that we represent a vector using line and arrowhead. So that's exactly what you are seeing on the screen. Okay, so some other time the two vectors can be acting in opposite direction, right? Which is example 2. If y and s act in opposite direction, then what will not be the resultant? So in that case, you simply subtract, since they are acting in opposite direction, right? So you simply subtract the magnitude of the two vectors. So in this case, one of the magnitude of one of the forces is 4 Newton, while the other one is 3 Newton, right? So if you want to get the magnitude, what you simply do is you subtract, okay? You subtract the two vectors. So in that case, we're having 4 minus 3, and that will give us 1 Newton, right? So the resultant of this vector in this case is 1 Newton. So let's move to the other slide. Okay, so we have another case. Sometimes, okay, two vectors can be inclined at an angle to one another, right? So in that case, you no longer use algebraic addition, just simple addition and subtraction. In that case, you no longer do that. But you now use what is called vector addition. And in vector addition, we use the parallelogram law of vectors. And we also use trigonometric ratio or scale drawing to obtain the magnitude and direction of the resultant. Okay, so let me go through it again. When two vectors are inclined to each other, the resultant cannot be obtained by algebraic addition. Okay, the resultant cannot be obtained by simple addition, just like we did in the previous slide. Okay, but in this case, you use what we call vector addition. And in vector addition, we use what is referred to as the parallelogram law of vectors. And we also use trigonometric ratio or scale drawing to obtain the magnitude and direction of the resultant. Okay, but in using the parallelogram law of vector, you must make sure that the angle of inclination, okay, between the two vectors must be obtuse or acute. Okay, but when they are inclined at 90 degrees to one another, or when the two vectors are perpendicular. In that case, we apply Pythagoras theorem to get the magnitude, right? So in the next slide, you will see all that. So quickly, let's run through what the parallelogram law of vector states. Okay, so the parallelogram law of vector states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from a common point. So the diagram below simply illustrates the law. Okay, so these are the two vectors, and the two vectors are inclined at an angle, right? And these two vectors are actually the sides of a parallelogram. So the sides of a parallelogram, okay, represent the magnitude and direction of the two vectors, while the diagonal drawn from the common point, which is point 0 here, represents the resultant of the two vectors. So let's move to the next slide. Okay, so on the next slide, now in vector notation, the sum of two vectors, right? Okay, in vector notation, if you want to write the resultant of two vectors, right? So that's what they mean by vector notation. So the sum of the two vectors are represented by arrow. Of course, arrow stands for the resultant, okay, which is written as arrow is equals to P plus Q, right? Where P and Q represent the two vectors, right? So the diagonal of the parallelogram is represented by the resultant arrow. Of course, I've said that earlier on. So we are going to be test running all these things that we've just said. Okay, so let's take, for example, example 1. Let us now consider the case when the two vectors are acting at right angles to each other. So if the two vectors are acting at right angles to each other, how do you get the resultant, and how do you get, okay, how do you get the direction of the resultant of the two vectors? Okay, so in that case, like I said earlier, I said in that case you simply apply Pythagoras theorem, right? So the magnitude of the resultant can be obtained from Pythagoras theorem as shown below. Okay, so for Pythagoras theorem, remember that Pythagoras theorem states that the square of the hypotenuse is equals to the sum of the square of the adjacent and that of the opposite, right? So arrow here represents the resultant, which is actually the hypotenuse. Okay, so the resultant is actually the hypotenuse of the right angle triangle that was formed by the two vectors when they are inclined at 90 degrees to each other, right? So arrow here stands for the magnitude. So if arrow is squared and P is squared and plus Q is squared, right? But you're actually looking for arrow, not arrow squared. So in that case, you take the square root of both sides. So to make things easy for us, right? So you just go arrow, since you are looking for the resultant, just say arrow is equals to then the square root of P squared plus Q squared. P and Q represent the vectors, right? So let's say the vector P has a magnitude of 30, while the vector Q has a magnitude of 40. So you simply simplify this, okay, you solve this, and at the end of the answer will be equals to 15 Newton, right? So you can as well still calculate for the direction of the resultant vector, right? So let's move to the next slide so that you can see how to do that. So to do that, you simply make use of your trig ratio, right? Your trigonometry. Right, now remember the direction of the resultant with respect to a given line. Okay, so the direction of the resultant could be with respect to the horizontal line or to the vertical line, right? Whichever one. Okay, so you simply apply your trig ratio since the two sides has been given to you and you are looking for the angle between the resultant and one of the vectors. Okay, depending on how the resultant is inclined, whether it's inclined to the horizontal, okay, or it's inclined to the vertical. Okay, so in that case, you make use of tan. Now remember your trig ratio. Tan is TOA, which is opposite over adjacent. So tan alpha, which is actually the angle you are looking for in this case, becomes opposite side all over adjacent side, which is from our previous calculation, which is P over Q, right? So this becomes 30 divided by 40. So in that case, you press, in order to get the value of alpha, right? So you simply, in your calculator, you press shift tan. So you look for the tan inverse, okay? The tan inverse of of 0.75, right? Because this is 3 divided by 4, right? 0 cancel as 0, so we're having 3 over 4. So 3 divided by 4 is 0.75. So you look for the tan inverse of 0.75, and that will give you 36.9 degree. Okay, now let's go to case 2. Now suppose the angle between the two acting forces is acute. Of course, if we say acute, it simply means that the angle is between 0 and 90 degree. Okay, or obtuse, we are saying the angle is between 90 degree and 180 degree. So in this case, you can no longer use Pythagoras theorem to obtain the resultant, okay, of the vector. So in this case, you use the cosine formula. So we can obtain resultant R, right, by mathematical method using the cosine formula. So this is a typical example of two vectors that are inclined at an angle, but in this case they are inclined at angle 55, which is actually an acute angle because 55 degrees between 0 degree and 90 degree. Now in doing that, recall your cosine formula, which is r squared is equals to f1 squared plus f2 squared minus 2f1 f2 cos theta. Okay, so cos theta here does not represent the angle that is given to you. Now, in order to solve this, okay, without any difficulty, first of all, you must understand some properties of parallelogram. Now, remember that the opposite angles of a parallelogram are equal, right? The opposite angles are equal. For example, this whole place here, angle A here, let's call it angle A here, is 55 degrees. That also means that angle C here is 55 degrees, right? Now, we don't know angle B and we don't know angle D, right? But they are equal, okay? They are equal because that is one of the properties of a parallelogram. Opposite angles are equal. So we can call here X and we can call here X. Now, remember that this theta here, okay, stands for the angle that is facing the resultant. So in this case, which is here, right, which is this 125. Okay, so we are assuming that the angle between the two vectors is 55, which is 125. So how did they get this 125? Now, what you simply do is that remember that the sum of angles in a quadrilateral, right? Your parallelogram is a quadrilateral, is equals to 360. So you add these two angles together, which is 55 plus 55, right? Or you can say 2 times 55 because the opposite angles are equal. So if one is given to you, then the opposite one will also be 55. Okay, so you add them together, that will give us 110, right? You subtract that 110 from 360. Okay, so that will give you a certain value. Then that certain value, you divide it by 2. So when you divide it by 2, one of them will be 125, right? So if you subtract 110 from 360, that will be equals to 250, right? 250. But remember that the angle B and D, they are facing each other. And you said, let the angle B be X. So if the angle B is X, that means the angle D is also S. So in that case, you're having 2S. So to get the value of S, you simply divide the result by 2, which is 250, you divide it by 2. And that will give you 125. So this is the angle, okay? This is the angle that you use here in place of theta and not 55 degree. So take note of that. So let's move to the next slide. Okay, so if you want to get the direction of the resultant vector, okay, we use what is called the sine formula, right? So the sine formula is simply, okay, so let's use this. This is a rectangle, right? The sine formula is simply this, okay, AC all over sine D, okay, is equals to CD all over sine A, is equals to AD all over sine C. So this is how it goes. Now, AC is this side, right? Why the angle facing this side is what is angle D. So that's why we have AC divided by the angle facing it, sine D, is equals to then CD. Then what is the angle facing CD? Is actually A. Okay, so that's why we have CD all over sine A is equals to, now AD, what is the side facing, the angle facing AD is C. Okay, but take note, in solving this, you don't make use of these 3 at the same time. You take any 2, okay, depending on the side of the triangle that is given to you. So you make any 2. So you can use these 2, you can use these 2, you can use these 2, depending on the side and the angle that is given to you. Okay, so let's move to the next slide. Okay, so we are going to be applying everything that I've been saying since to solve some problems. So let's begin with example 1. A body of mass 20 kg is set in motion by 2 forces, 3 Newton and 4 Newton, acting at right angles to each other. Determine the magnitude of its acceleration. Determine the magnitude of its acceleration. So let's move over to the board to solve that problem. So we are told in the question that the two forces are at right angle to each other, right? So let's say this is the 3 Newton force and this is the 4 Newton force, right? Okay. Now, but we are asked to calculate acceleration. Remember that F is equals to ma, because in this question we are given mass actually. Okay, mass to be equals to 20 kg, right? And we are asked to calculate also for acceleration. Of course, we simply make A the subject of formula here by dividing both sides by m. Okay, so that A is equals to F, right, over m. So this is the formula we use in solving example 1. Right now, but this force, remember when we were discussing about Newton's law of motion, and when we arrive at this formula, I told you that this F here stands for resultant force and not just any force. Okay, stand for resultant force. So in order to get this force, okay, in order to get the value of this force, we must look for the resultant of these two forces, right? And to look for the resultant of these two forces, we simply have to apply Pythagoras theorem. So let me do this. So this is the resultant. So let's write arrow. Of course, remember that this 3 Newton force is parallel to this side. So we can do that and put the 3 Newton force there. Okay, because these two sides are parallel, so they are equal, right? So in this case, we can apply our Pythagoras theorem, right? So R, which is the resultant, is equals to root, okay, 3 Newton square plus 4 Newton, 4 Newton square. So in that case, R is equals to root 9 plus 16, right? 9 plus 16. So R is equals to root 25, right? And root 25 is equals to 5 Newton. So the resultant force that we are going to be using here is 5 Newton and not one of these forces, okay, and not one of them. Take note of that, because this F here stands for resultant force, okay, stand for resultant force. So take note of that. So we simply substitute what is given to us here into the equation, right? So we know that our A, okay, we are looking for A, we know that our F is equals to 5 Newton, and we know that our M is equals to 20 kg. So in that case, we divide, right? So 5 here is 1, 5 here is 4, isn't it? So we have 1 over 4. So 1 over 4 is the same thing as 0.25. Okay, 0.25 meter per second square acceleration. So how did I get my 0.25? Okay, 4 into 1 cannot, so you write down 0 and you drop point. So immediately you drop point, you put a 0 in front of the 1. So how many 4 is in 10? That is 2 remainder 2, right? So you write another 0 in front of that 2. Okay, 4 into 20, and that will give you 5. So that's how I arrive at this answer. So the acceleration is 0.25 meter per second square. Okay, so this is where we'll be drawing the curtain for today's preview for this video. Okay, but if you want the complete video, you can always click on the link in the description below, and this will take you to my school website. There you have to subscribe to enjoy the complete video. So in the complete video, we completed solving the remaining 2 examples. Then we went ahead and discussed about how to resolve forces into their component when the forces are more than 2, and we also did a lot of examples there. So I really wish that you subscribe so that you can enjoy and also learn about how to do that. Okay, so I believe you enjoyed this video. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly tap on the notification bell to get informed as soon as we release the next video.